The radiation above the Earth is driven by the changing activity of our sun.
We really start by trying to look at what the sun is doing, and that will give us some indication of what's likely to affect the space environment around Earth in the next minutes, hours, and days.
Dan and his team look for solar flares, super-energized radiation particles that are released from the sun and stream towards Earth.
Energetic particles from the sun can probably be thought of somewhat accurately as tiny but very powerful bullets that are being generated by the energy on the sun. Those powerful bullets, if they were to strike a spacecraft, they could cause damage within a spacecraft or within the electronics of a spacecraft.
But in fact, the Earth is incredibly well protected from these solar bullets by its remarkable magnetic field.
We have this wonderful protective umbrella above us. The Earth's magnetic field prevents much of the powerful energy from the sun.
This magnetic force field shields the Earth in two ways. It deflects some of the dangerous particles back into outer space, but also traps some radiation, holding it in a layer that comes as low as a few hundred kilometers above the Earth's surface.
So we have both the fact that the Earth's magnetic field, in a sense, prevents radiation from getting very close to the Earth, but it also provides a trap for particles to be embedded within the magnetic field for long periods of time.
Beneath this dangerous blanket of trapped radiation, the International Space Station and many of our key satellites fly in what is called the low Earth orbit. But this safe zone doesn't always provide the protection that scientists expect. That means any astronauts passing through this zone need to be monitored. And that's the job of Kerry Lee and his team.
We're in the multi-purpose support room, which is a back room in mission control at the Johnson Space Center. And our goal here is to keep the astronauts protected from space radiation. Valid until 09, huh?
Yep.
Okay. Thanks a lot. I appreciate it.
All right.
On board the space station, live radiation data is beamed back to Kerry, and it reveals what happens when the International Space Station flies over the South Atlantic.
You can see there are some irregularities that happen at various places within the low Earth orbit. We see 6 or 7 of these peaks each day.
These peaks in radiation occur each time the space station passes through the South Atlantic anomaly.
When the International Space Station passes through this intense region, over here you can see individual frames and the intensity increases where you have more hits in the detector.
Over the South Atlantic, the trapped radiation that should be held safely above the Earth dips down into the low Earth orbit, creating this radiation hotspot, the South Atlantic anomaly, much closer to Earth than expected.